Assalamu alaikum, dear students. My name is Muhammad Haris, and today we will learn about function. So basically, prior to learn a function, we should learn about what is a relation, because the definition of relation, we should know this will be used in the function. If someone don't know the definition of relation, that what is a relation, he would ever never be understand the definition of function. So the function is totally uh, based on the definition of relation. And after that, once we complete the definition of the functions, we will learn about what is domain, what is codomain of a function, and what is the range of a function. So let us take start with the definition of. So dear students, in these slides we will learn the definition of relation. Let A and B are two non-empty sets. A and B must be having some elements. It should not be a non-empty set. Then their Cartesian product denoted by A cross B, and it is always defined in these forms. A cross B is equal to, start with the middle brackets, and the small open the small bracket, A comma B whole such date. This notation we used for in mathematics for such date. A belongs to A, the first element belongs to the first set A, and this notation we use for and B belongs to B, the second element will be belongs to the set B. Let us understand more precisely with the examples this definition. A and B here are with us two non-empty sets, as we discussed here that A and B are two non-empty sets. So A and B are the two non-empty sets with us. We are taking the Cartesian product A cross B here. A cross B is equal to, the first element of the set A will come with all the elements of set B. So 1A, 1B. 1 has come with the elements, the first element of the set A, and then 1 has come with the second element of set B. So it finished. Then we comes to the second, 2A and 2B. Similarly, we can write the 3A and 3B, and close the brackets. Now we are taking any first binary relation. Any binary relation we can take, and we can give with them R1, R2, or 3 like this. But for R1, what is R1? As we say, this is a subset of A cross B. So we are taking any relation R1, 1A, 2B, and 3A. This is a subset of A cross B because all the elements of R1 is there and the elements of A cross B. So R1 is a subset of A cross B. Similarly, we can take another relation R2, 1B, 2A, 2B, 3B from the A cross B. Now these subset R1 and R2 are the subset of A cross B, and these are called and it is called binary relation, and these relations are called binary relation. R1 and R2 subset of A cross B is called binary relation. So I hope so now you understand what is a binary relation. Any subset of A cross B is called a binary relation. Know the definitions of function. What is the definition of function? If A and B are two non-empty sets, A and B must be having some elements in the set B, as we discussed earlier. Then a relation R subset of A cross B. Subset of A cross B is called function. Look at here, we said the relation R subset of A cross B is called function. So the definition of function is based on the relation. If and only if it follows the following two conditions. The first condition is every element of set A have exactly one image in set B. The second condition is there should be no repetition of the first element in the binary relation. Let us understand this definition with example. A and B with us are the two non-empty sets, A and B, and here we are presenting these two sets, A and B, with the Venn diagram. What is the first condition? The first condition is every element of set A has exactly one image in set B. So every element of set A, 1, 2, 3, these are the elements of set A, have exactly one image in set B. So look at one image is A, two images B, three images B. So every element of set A has exactly one image and set B. So it satisfied the first condition. It satisfied this first condition. Now we come to the second condition. The second condition, there should be no repetition of the first element in the binary relation. So come here, this is a relation, binary relation, If we look at the first element is 1, 2 and 3, and there is no repetition in the first element of the binary relation, so it also satisfied the second condition. And if we look at this relation here on Venn diagram, so the one image is A, one image is A, two images B, three images B. One image is A, two images B, three images B, and there should no repetition in the first element of set B. So this satisfied both the conditions are satisfied here with us. 1 and condition 2 are satisfied with us, so this R is a function from A to B. And we will write it like this: f is a function from A Okay, dear students, here we are going to study some examples of functions. So here we have two sets, x and y, and what is the definition of function? You must be remember it, because from the previous slides we have learned it. For every element of set x has exactly one image and set y. So for 1 there must be one image and set y. Similarly, for 2 we have exactly one image and set y, which is C. For 3 we have exactly one image and set set y, which is A. So every element of set x every element of set x has exactly one image and set y. So it follows the condition of the function. So f is a function from x to y. So simple, yes? Now let us come to the second example, and we say that two sets are given here, x and y, and we are presenting by Venn diagram. We are considering one relation. For 1 we have the image B. For 2 we have image C. For 3 we have image A. And similarly, and lastly, for the 4 we have image C. So every element of set x has exactly one image and set y. But if we look at here, D is not the image of any elements belongs to set x. But it does not contradict with the definition of function, because in function we have learned that for every element of set x we have exactly one image and set y. So it is a function. And the next slide we will learn what are the functions, what are the relations which are not be a function. So let us Okay, so let's come here. Here we are going to presenting some examples which does not satisfy the definition of a function. If we look at here the elements of set A has exactly one image and set B. For 2 we have got two images. For 2 one image is Y and one image is Z. So for 2 we have got two images. So this is which does not satisfy the definition of a function. So this is not a function. F is not a function because for elements 2, this is 2. For elements 2 belongs to A has two images and set B. So it does not satisfy the definition of a function. This is not 3, okay, this is 2, okay. So 2 belongs to A, does not satisfy so the definition of a function. So look at here for 2 has two images, and what is our definition? For every element in set A has exactly one image in set B. So even though if we look at here, if we have here another element, let's suppose 4 is, let's suppose I am taking here let's suppose here we have another element 4 and for 4, if you don't have any image and set B, then this is also not a function. It will not be a function, because and the function definition we say that for every element there must be exactly one image and there for every element, but here we have two images, so f is not a function. But even though if this is a has one element, for 2 we have got one element, one image in set Y and set B, but if for 4 we don't have any images, then it will not be a function, because for every element we will have exactly one image in set B. So now onwards we will study about the domain. Hi students, and so now we are able to define domain, codomain and range of a functions. With these examples, I hope so that inshallah we will learn all these about 3 points: domain, codomain and range of a functions. And then with the next slides we will learn it with the Venn diagrams, and then it will be very easy for us to solve the complicated questions of functions. These are the basic tools. If someone learn it thoroughly, understand it completely, so it will be very easy for them to understand the questions of functions in the next lectures. So let us A and B here. A and B are given to us two non-empty set, and they said and f is a function from A to B. It is defined like this. It is defined like this: f of 2 is equal to 1, f of 4 is equal to 3, f of 5 is equal to 6. Then find the domain of f, codomain of f and range of f. So first we will learn the domain of f. Look at the domain of f is A is equal to 2, 4, 5. Look at, always be remember that the set A element with us are the domains of the functions. The domain of a function, these will always be the domain of a function, the set A element. So here I have given to note that the set A elements are called domain of the function. The set A elements are called the domain of the function. So look at these 2, 4, 5. Actually this is f of 2, 4 and 5. These are inputs of the functions. These are our inputs of the function. When we put a 2 value in the function, it gives us 1. When we give 4 and put 4 in the given function, it will give us 3. And we give 5, it gives us 6. So these inputs 2, 4, 5, or you can see the set A elements, 2, 4, 5, which are basically the inputs of the function. These are called the domain of a function. So now you understand what is the domain of a functions. The input values of a functions, which is usually denoted by x, so are called the domain of a function. Next we learn the codomain of a function. The codomain of a function is, what is the codomain of a function? They said B elements, all elements of the set B, 1, 2, 3, 6. These are called the domain of a function. It's just be remembered that all the elements of set B are called the domain of a function. So the range of a function. You know what is the range of a function? The output element which gives us from the defined function, with 2 gives us 1, 4 gives us 3, when we put 5 it gives us 6. So these outputs are called the images of the function f, the range of the function, sorry, these are called the range of the function. So here now we have we are in the position to differentiate between the domain and range of a function. What is the codomain? Sorry, the codomain and range of a function. So what is the codomain of a function? The set B elements. All the elements of the set B are called codomain, and the output values of the inputs, these are called the range of a function, or you can say the images. 1, 3 and 5, 6 are the images of the function, are called the range of function. So very easily we can identify the differentiation between the codomain, range and domain. What is domain? The set A elements are called domain, set B elements are called codomain, and the output values or the images are called the range of a function. Now we can also define these domain, codomain and range, or with the Venn diagram as well in the next slide. Dear student, this is the last and final slides for understanding the domain, codomain and range of a function. These descriptions for the domain, codomain and range of a function on Venn diagram. This set A and set B has been described here by the Venn diagram. So now what is the image of 2? The image of 2 is 1. Image of 4 is 3. Image of 5 is 6. And this is already been given in the question and your book. The function is defined by this: f of 2 is equal to 1. F of 2 is equal to 1. Look at this 2. This 2 is our input and the output is 1. This is output, or we can say the image. 1 is the image of 2. How we will say it? 1 is the image of 2. So for 2 our image is 1. When we put 4, we will give the function will give us 3. When we put 5, the function will give us the output 6. So now come to what we said in the previous slides. that all the elements of set A is called domain. And what are these elements? These are actually the inputs 2, 4, 5. 2, 4, 5. These are the inputs. So the inputs of the functions are called domain of the function. And here we will write like this. Domain of the function is 2, 4, 5. What is the codomain of a function? The codomain of a function is 1, 2, 3, 6. Meaning all the elements of set B is called the codomain of a function. Now, for the last and final is the range of a function. So the range of a function is the output or the images of the function, which is 1, 3, and 6. So what is the difference between the codomain and the range? Most of the students, they get confused. They cannot differentiate the difference between the codomain and range. So please keep this in mind, that all the elements of set B is called codomain, and the image or the output of the function is called the range of a function. What is the range? All the images of the function is our range. So from this entire lecture, I hope so that you will understand and you will have a very good understanding now with the function, domain, codomain, and range of a function. Please keep watching my lectures. In the next lecture, we will come to know about the linear function, quadratic functions, and applications of these functions. So thank you.